Okay, let's get started. Happy New Year, everyone. I know it's about 12 days into the new year, but welcome to the first episode of Yugabyte TB Friday Tech Talks for 2024. My name is Kannan Muthukarupan, one of the co-founders at Yugabyte, and my pleasure to welcome you all. So I'll hand it over to Alan, who is the speaker for today's topic. I'd love for him to introduce himself and then get going with the topic.
Okay. Thank you, Conan. Happy New Year to you as well. Hello, everyone. My name is Alan Caldera. I'm a distinguished engineer here with YugabyteDB. I've been with the company now about 5.5 years of our almost 8-year history. It's my pleasure here today to impart some more of my knowledge and my love for Postgres in general. And one of the reasons why I really enjoy working with YugabyteDB is it allows me to continue my love for this product. There we go.
Yeah.
Okay. So today's topic is around event triggers. And those of you who have been around Postgres for a long time probably are familiar with them. Those who have not probably go, oh, what are those? So event trigger. So we all know and love regular triggers sometimes, depending on who you are, that can do actions on tables where you can do before, after, insert, update, delete. These event triggers were originally committed by a gentleman by the name of Dimitri Fontaine in Postgres 9.3 more than 10 years ago. So these have been around for a while. So basically, they are actions that can be taken on database level DDL, i.e. when you're running most, and I'll tell you the exceptions, create, alter, drop, security label, comment, grant, and revoke DDL operations. So the exception here is if you are trying to create an actual database, a role, or like create role, drop role, alter role, and create or drop table space. Those objects are at the global level in Postgres and not in the actual database catalog itself. And so these actions, go ahead, Connor.
It's cool you know some of the history of who added these features in Postgres 9.3. Awesome.
Okay. So actions that we take inside of in Postgres. So the actions that we can take inside of these triggers can be additive, i.e. you can add operations like, inserting it into tables, or perhaps, creating new logic to do other actions that are capable that you can take within Postgres, and that you can also prevent actions. So you can look at, oh, what's the size of the table? What's the time of day? I can go read other tables to say, okay, well, I don't want to run. I can do things like I don't want to run certain statements between midnight and 3 a.m. when things like my backups and stuff like that are running. But the thing is to remember is that no, you can't actually change the contents of the statement itself. So what can they be used for? Well, so the most obvious one is our old friend PG Audit that goes ahead and allows you to log into the Postgres.log file various actions that happen so that you can basically turn those over to your company auditors to say, okay, well, these are all the actions that happened during this past period, who was given permission, what they actually did, things like that. I don't always enjoy the trying to go through text logs, so I sometimes prefer to actually log them to actual tables. because then I can be a little bit more selective on what actually comes out, and I can without having to grub through a lot of logs. Some things that are probably a little less obvious. So I mentioned about permissible operations. Being able to say, hey, no, I don't want, while you have permissions at the via grants to say, okay, well, this user can create tables and alter tables. You may not want them to do it at certain times, or you may not want them to do it from certain ranges of IPs, or you might not want them to do it on certain sizes of tables. So this is where some of the management can come into play. And then also you can do cool things like say, you know what, I want to enforce some standards in how how objects are named. I've been a DBA in a number of environments, and sometimes I find that usable.
Or would we be able to have enforcement like, okay, I want to make sure all my timestamp columns are like timestamps with time zone and things like that, like.
Yes, I believe that is possible. It involves a little bit more parsing, depending on how much you enjoy parsing
Maybe we get we'll get to it later. Like I'm guessing, why don't I bring this up in a later?
Okay. Sure. Okay. And then finally, things like task automation. In some instances, you can do things like create schemas implicitly. So if I say create table, some schema name dot my table, and that schema name doesn't exist yet, you could actually write one that says, I want to go ahead and create the schema first. You can also do things like create indexes on foreign key columns. So this is useful when when the system has to back check whether a row can be deleted or not. It's nice for it to actually use an index, and also when you're joining. And then finally, if you want to really get sophisticated, if you want to say, okay, I want to automatically update views as columns are added or dropped. Okay, so how are they actually defined? So, there's the usual verb is create event trigger, and you can give it some kind of name, that complies with the standard identity naming rules. On an event, and we'll talk about what events are possible here in a moment. And then it gives you the optional ability to say, okay, well, I only want to fire this trigger when certain conditions are true. So things like, I want only to run this particular trigger if my tag is create table or create index, but not anything else. But you can also add operations, from that, are represented, in Postgres's level variables. So you may only want to do these on certain schemas. So you can say where the current schema is in a certain list, etc. And then finally, the action that we're actually going to take is, we're going to execute an actual function that I'll show you an example of. And finally, you're saying, okay, well, sometimes I may not like, some of these rules. So you do actually have the ability to say, okay, well, I want to disable, I may need to, break the prohibition on creating a table in this window because we've got a production outage. So I can basically turn the event trigger off while I'm doing this emergency action. So events. So there are basically 4 types of events in Postgres. So they are DDL command start, which covers all DDL commands that are permitted, the aforementioned list, create, drop, alter, security label, revoke, grant, comment. Then you have table rewrite that only works on certain alter commands, SQL drop that only works on specified drop commands, and finally DDL command end, which happens right at the end of processing before it's all committed, and that covers all commands that are legal as well. So there is an order of precedence in how these things are actually executed. It flows from command start through table rewrite, command end, and finally SQL drop. So you can define multiple triggers for a given event. You can, like everything else, the more objects it has to go through, the slower it might be. So there is some benefit in actually there is actually some benefit in coalescing certain groups together and doing more sophisticated if-then logic to exactly control what you do. But I for low amounts of procedures, I like to have them separate, because then I can atomically control which events I really want to suppress at a given time. Okay, so I talked about supported commands for table rewrite and SQL drop. Drop covers most things that talk about dropping some kind of object in the system. Alter is a little bit different because not all alters cause table rewrites. So typically you have to, the list of alters that actually qualify for table rewrite is actually pretty small. It's what I've been able to determine from the documentation is that they only really qualify in alter table and alter type. So digging in a little bit further on DDL command start. So basically, DDL command start will fire before any validation on the top target object occurs. So yes, you can make a syntax error in your statement, and you're going to get a DDL command start event firing. So this is the place where I like to use DDL command start is basically it's the best place to really intercept and prevent the execution of a certain statement. So when you talk about things like I want to check what time of day it is, or I want to check what size of potentially what size the object is, I might want to do that first in a DDL command start. Unfortunately, you don't have a whole lot of information at this point because it hasn't really filled out all of the information yet. You basically have access to the current query statement, but not much else. Not much else in terms of actual lookups from the system catalog yet, because it's not there. So the other thing is that I mentioned that most things that trigger events are the statements I was alluding to earlier, but we have a little exception here. So that is when you do select blah into table name, that implicitly creates a table underneath. So you will actually get an object implicitly created at that time. So, okay, what does one of these things look like? So this is an example of a DDL command start function. So in this example, I'm basically saying, okay, I'm going to do a little bit of a raised notice here to basically log it out to the screen that says, okay, I've caught my event. And then I'm going to basically just put it in the my own little DDL log. So if I want to actually, if I actually want to stop execution at this point, I could actually say something like raise exception. Hey, the time is outside the time window, so I'm just going to raise exception, and then basically that stops all execution of the statement and prevents the action entirely. So here I'm showing a sample execution of what it looks like when that event fires. So I went ahead and created a table called T_PG key value, and it says, okay, I caught this event, and then it went ahead and logged the statement as well as from which IP and the time. So the next one is table rewrite. So this fires before what happens in alter table or alter type. Basically, it gives you two helper functions to basically, because it hasn't really happened yet, it gives you basically, okay, here are two things that here are two things that you might want to look up to basically say, okay, what is actually being modified. So you can look at the scalar called PG event trigger table rewrite OID. So you can use that to look up into PG class and look at this, look at some of the properties of the table. And the other one is basically saying, okay, well, I want to basically figure out, okay, well, why is the table being rewritten? And so basically it provides a bit mask of 4 potential values. The first and last one deal with persistence. Persistence is when you're talking about in Postgres whether a object is logged or unlogged. And then the OIDs, we don't support OIDs within tables. I'm sorry, as part of tables. They can be columns, but you can't say in some cases you can actually say, okay, I want to add OID so that I can have a stable row ID for a given row, but we do not support that. So the only two that could possibly apply to us are rewriting default vals. That one I'm not sure that that actually it does a rewrite because we do some interesting things under the covers to basically just update the catalog such that further writes basically start materializing that value after the default is done. So I don't actually think it actually rewrites and it'll.
Alan, are you talking about the rewrite case or the one before the default val case?
The default, yeah, the default val case.
Yeah, the default val case, yeah, there are some optimizations where we avoid rewriting the entire table to backfill the old value and implicitly materialize it. That's true.
Yeah. And then the column rewrite case where basically you're saying you're modifying the type or modifying the actual size of the column. This is again, I think this is kind of dependent on whether we actually rewrite the entire table.
Correct. Yes, there are some type changes that are sort of on disk format compatible. Like if you're just increasing the size of a car10 column to car20, then it doesn't really need any on disk change. But sometimes if there's a type change, and if corresponding on disk change is needed, then there's a kind of a table rewrite that has to happen. Yeah.
Okay. Okay. So this is just an example of where we would use the two scalars to actually give us some additional logging in this case.
And basically, like I think maybe okay, so you're creating the stored procedure like log all DDL changes, right?
Yeah.
And I think you're not showing the create event trigger step, but that is assumed you'll create an
Right,
event.
there's actually a create event trigger where I actually register these
Yeah, you
functions.
attach this function to to uh, to the table rewrite event. Yeah.
Yes. Okay. Uh,
One more question, Alan. Like suppose I've already attached a function to a table rewrite event,
mhm.
uh, and now I attach function two to the same table rewrite event.
Mhm.
Then do both events fire? I think you maybe covered
Yeah,
this.
so they both fire, but they fire in order of the actual trigger name alphabetically.
Ah, so Postgres has taken the approach that instead of raising a notice or an error saying, "Hey, there's already a
Right.
event trigger attached for this
Just let it
particular."
happen.
Okay, got it. It allows multiple triggers of the same event type, but it just runs them alphabetically. That's interesting semantics, but I guess we replicate it faithfully.
We replicated that, completely faithfully since we took the top half of Postgres.
Okay.
Okay. SQL drop. So basically, so this gets fired when after the actual target object is actually already gone. So this basically reports on all of the this basically returns a set of actions that it took. And so, before I'm here to kind of disabuse you of the notion that, it only drops one object, but actually, it's a lot more. So this is the schema of what this table valued function returns. So there's a number of things that you can test for and give, perhaps, customize with your own logic. So in this case, when we go to actually execute an a drop, so I'm dropping the key value that I did earlier, and you can see that it actually drops a table, the sequence, a type, the default value, the constraint, the index. So there's a number of things that actually have to get you actually get a fire for all of the different things that it's removing from the
So,
catalog.
Alan, why is it dropping things like the type, even though you didn't use a drop table cascade?
Yeah, so this is just because it's basically saying, okay, well, these are all the sub actions that happen. So because you have entries not only in PG class, you have entries in PG attribute and PG sequences and PG constraints. So all the different actions are having to be taken there.
Got it. Got it. And if you had if this table had an index, it would have dropped that.
It would have dropped it as well. Yes.
And essentially this helper function, if you go back to the previous slide, inside your trigger in the for loop is where you're using this helper function.
Yes.
And unlike the previous helper functions, this is a table function, which is actually returning a set of rows.
Yes.
Correct?
Yeah.
And so that is cool. Yeah. Thank you.
Okay. So finally, we come to DDL command end. So basically, this fires after everything else has occurred, but before it is actually committed. So this is this happens. This happens at the end of all things, but you can actually still basically intercept certain things at this point, and I'll show you an example. Yes, so there was a question from the floor. Yes, this is yeah, so this does work in the question from Colt. Yes, this does work in a distributed manner. So basically, these are all running on this is actually running at the Postgres layer. So everything everything that happens is happening, whether it's, whether it's having to drop tables and, multiple tables, multiple indexes, those indexes may be on other nodes. And so basically it's processing all of that on the node that you are actually connected to.
Yeah, and like if you could, for example, go to the slide 14 as an example. And the question was, hey, for example, if you're using some kind of hash sharding, and if your trigger instead does an insert, if you could go to slide 14, perhaps.
Yeah, I'm on.
Yeah, you're on it. Yeah, so if your trigger does an insert to another table with a different key, does that work? So in some sense, if you look at this slide, this trigger is writing into kind of an audit table, and it's called my DDL log, and that has its own sharding going on. It could be a very large table that's growing, and it'll just work. So essentially, the DDL that triggered this event trigger could be running on node 1. So that's where the trigger might fire. But the fact that this insert into my DDL log, this my DDL log table could be distributed any which way, and we do the right routing and make it all happen as part of the parent transaction. Okay. Thank you.
Sure. Okay. So I alluded to the ability to enforce things like table naming conventions. So this is actually an action that we're taking in DDL command N, because now I have all of the information about what the user actually tried to do. And so I'm basically looking at, again, I'm using the set of records coming back from PG event trigger DDL commands to look at what actually they were trying to do. And so I'm using a little helper function to parse the identifier to say, okay, what does the table name actually look like? And then I'm raising an exception if it doesn't qualify for my rule here. And then this is an example of how that works. So I tried creating customers without it, and it says no, it has to, the table name has to begin with T underscore. And once I fixed that, it went through just fine.
And Alan, if you could go back one slide, what is the helper function you use is
it's parse ident. But it triggered the PG event trigger DDL commands. To actually loop through all of the all of the things that got generated by that statement, and then parse ident is one of those nice little scalar functions that exist to make life easier for PLPG SQL developers.
So unlike the other table function, for this case, does PG provide any helper to say, hey, the create table is happening and it has these 5 columns, and these 5 columns are of these particular types, or it currently doesn't, and we have to do the parsing?
Yeah, so this basically, these are all the things that it covers. So you have like the attribute number for the column, you have the tag, so you can filter on all of these things. Then you have the actual, you can even be really sophisticated and say, hey, did this come out as part of a extension? Was this done as part of an extension?
Got it. So the full text of the command is in the last column.
It is in some versions of Postgres, though it's not very reliable, and so that's why I use current query.
Got it.
Yeah, there actually there are, but speaking of that, there are resources out there on the web that actually help you basically take the catalog entry and basically give you a way to reconstruct the entire object. So if I was dropping an object and I was like, well, what was the schema for that object? Because now it's dropped, I don't know what it is. You could actually go reconstruct from the system tables before it actually drops, what the actual object looked like before it was dropped.
Yeah, that makes sense.
So, finally, if you want to kind of look at what kind of event triggers you have, YSQLSH or PSQL, whichever one you like to use, has a command \dy that will list out all of your event triggers and their statuses and what they're created on. You'll notice that in the naming convention, I purposely prepended ZZ to indicate that I wanted the logging to happen absolutely last. So that I was making use of the semantics of the ordering to make sure that I wanted to execute those things last.
If there are two entries for the same event type.
Yes.
And
Yeah.
what are the tags in the last column? What does that mean? The create.
Okay, so that actually, so this is when this is basically when there's a filter condition. Okay, so when I created, you remember in the create event trigger syntax, there's a when clause, and so basically this is where it logs what the predicate was for when this trigger is allowed to fire.
Got it. So instead of all DDL, if you just wanted to focus on create
table, create index,
Yeah.
top table, drop index, that's where you would do this.
Makes sense.
Okay. So we're running a little short on time. So I'm not going to do the live demo. I'm just going to quickly look at, just show you this cool example where you can actually use DDL command N to automate the actual creating of indexes on foreign keys. So I've included the code here. In there is a nice nasty little bit of SQL to basically figure out, from the system tables what the what the columns are, and then there's an important clue in when you go to execute. If you're going to execute like things like create index statements, usually they are by default done concurrently for performance reasons. But that would not be a good idea to do inside of a transaction block, and we actually prevent that. So you actually have to explicitly say create the index non-concurrently.
Got it.
And then I show an example here where you say, okay, where I want to create table T orders, and I've got a referred column to the customers table that I created earlier. And you can see that it actually goes ahead and creates the index on the foreign key column. Okay.
Yeah, basically, even if you can use it to intercept the DDL to create necessary indexes in summary, right? And for foreign keys, Postgres doesn't create an index by default. Am I correct, Alan?
Yeah. No, it does not.
Yeah.
One of these days it might. But see, with this feature, you can do it now.
Wonderful.
Okay.
Thank you. I think we're about on time, but thank you everyone for joining for another episode of the Friday Tech Talk. And we'll see you again next week. And Alan, if you want to have any closing remarks.
No, that's have fun with these. I think the Postgres community in general doesn't really appreciate the power. We're actually here at Yugabyte. We are looking to use this, within our own product to automate certain tasks that come up in some of our more interesting deployment scenarios. So would like to see more people use this wonderful extension to the language.
Thank you. Thank you all. See you next time.